Hello, everybody. We are continuing our math ACT videos. This time, instead of me working and explaining some and then giving you some to work, I picked three that I'm pretty confident that most of you guys will know how to work on your own. So what I'd like you teachers to do for me, if you would just go to the video until it zooms in, let the students have a couple of minutes to work each problem, then you can restart the video. It'll go to the next problem. And then after you've paused for the third time, and you start the video again, it should be me just explaining the answers to the problems for the students. So let me go ahead and go to the first problem. Okay. And that's not it. Hang on. Okay, here's the first one. So if you teachers would just pause and let them have a couple of minutes to try to work this one out. These all have to do with similarity. Okay, hopefully they have paused. Here's the second problem I would like you to try. And now here's the last problem. And like I said, after you guys start the computer back up, it should be me explaining those three. All right, so here we go. So if you look at these problems, anything with similarity, and similarity is something you learned in middle school, but you also got reintroduced to it in geometry and maybe even in some of your other math subjects. But the big thing about similarity is you're going to have two figures, one bigger than the other one, and they've had some kind of multiplier, many times a whole number multiplier, which makes the problem a lot simpler. But you could also set up a proportion. So for number 7, I'm going to show you both ways. Now you do have to be careful about number 7 because if you notice the problem says they're similar triangles, but they're not asking you for the length of this missing side. They want perimeter, which is adding all the side, it's going around the figure or adding all the sides up, in this case, 3 numbers. So be real careful with reading the questions carefully. But I can see that this DF is going to correspond with this bigger side AC. And so, again, we're going to set up a proportion first, but then I'll show you how to do it without. So you basically are going to take the corresponding sides of 5 and 10, and 5 over 10 has to equal, and go back to the smaller triangle now, smaller over big, smaller over big, which would be 6. And then when you do that cross multiplication, you would get 10x is 30, so x is 3. Now, again, that's one of the answers, but that's not the answer that we're looking for because we need the perimeter. So now we're just going to add up 3 plus 3 plus 5 to get the correct answer of 6 plus 5, which is 11. So this should be answer number C. But a lot of you guys are going to notice that this is a whole number multiplier, right? This triangle is twice as big as this smaller one. So 5 times 2 is 10, 3 times 2 is 6. So we also need this side to multiply by 2 to give me this other 6. So that's another way to easily get this missing side quickly so you can go on and get the perimeter. Okay, let's scoot up to problem number 2. Really super similar to problem number 7. But now here's the only issue with this one. If you notice, it is another multiplier, even whole number multiplier. 6 times 2 is 12. So you might want to guess that you can just do 5 times 2 is 10, which you can, and 4 times 2 is 8. And if you notice that these lines were parallel now, that's what makes these triangles similar. You've got a small triangle, a medium triangle, and a large triangle. And they're asking you for the length of AC. So these little small sections, 3 of them all add up to AC. So 22 plus 8 should be choice D here. But you do have to be careful with this one because anytime you have these triangles inside of triangles, it's a very popular scenario, quite frankly. But when you think about what you're comparing as you do your proportions, because you could also set up a proportion on this one like we did the first one. But when you compare 6 and 12, you're comparing a whole side of one triangle and a whole side of the other. But when you come down here, you're not comparing DF. It's not a whole side of any triangle. It's just a little section of the middle triangle. But we're okay because 10 is also a little section. But what you have to be careful about is, let me just scoot this over and kind of redraw another scenario much like this one. If I drew that top two triangles and I said 6 and 5 and move the 12 right here, and I said X, well, you can't do what we were doing. You can't go 6 times 12, 6 times 2 is 12, so 5 times 2 is going to give me my answer, because you're comparing, again, sides of a triangle. Here you're comparing a section of this bigger triangle, but you're comparing a whole length, a whole side of the big triangle, not this section over here. So you would end up having to put 6 over 12 equals this whole amount, 11 over X. So just be real careful if you see that. Just think about what you're comparing, and you should be okay with that. Okay, the last one, the only difficulty with the last one, one of the difficulties is they gave you this number 10 that doesn't get used at all. So unfortunately, some students are going to try to use it, make the numbers fit together and say, 10 minus 8 is 2. I don't know, something like that. But that's not going to get used at all. But what is going to get used, kind of like what we were talking about just a minute ago. And the problem, they said these were parallel. That gives me those similar triangles. And they are looking for this one. They're looking for DE. And when you think about, if they told you in the problem that BD is equal to AD, well, if you want to think about what would happen there, and you really could just make up some numbers, quite frankly, let's just make up, you could put an X there or a different variable. Let's just put a 2. If that's 2, then that's going to be 2. Well, again, you have to be careful here. This is the scenario I was talking about. If we're going to set up some kind of proportion and say do 2 over X, well, you can't then come down and do 2 over 8 because you're comparing a whole side of a triangle with a section. But we could sum these up and then do 4 over 8. And then again, do the cross multiplication. So X is going to be 4 here. So X will be H. So again, just be real careful when you're dealing with these triangles inside of triangles that are similar, that if they're not comparing a section here, you don't want to be using just a section here. Okay, that will do it for today's video.